Okay, hold on real quick. So I'm going to give you a hint. You have to start, everyone, we started with our given. What's our given?
16 grams.
Of what?
Oxygen.
Oxygen, right? And so a lot of you have been converting that to moles perfectly, right? So how many moles of oxygen do we have? That's what we need to work on. So 16 grams, we need to convert that to moles of oxygen, right? What's the molecular weight of oxygen? 16, I'm going to hurt you. 32, right? Wrinkle high, right? And then, what do we just write in this last slide? What should we treat coefficients as?
Moles.
Okay, so for this reaction, there's 1 mole of oxygen. Per 1 mole of oxygen, how many moles of water are produced? 2, right, from the coefficients. Okay, go, keep going. Hey, all right, that's what we want. What did you say that? No. Remember, if you want grams of oxygen, to go that to moles, you can't use hydrogen or water. You can only use oxygen.
Okay.
For that to be canceled. So what's the molar mass of just oxygen?
32.
Right, so we're going to put 32 here. Over what?
Over 1 mole.
I mean, on top of it. So now this cancels, right? Because GO2, GO2. So now you're in moles of oxygen. Okay, now you're on the right track.
Okay. Thank you. Sorry.
So that's if you're going 600 measure of just oxygen. We're going to go from moles of O2 to moles of water.
Alright,
So now you're in moles of O2. Look at the coefficient. Look at the coefficient. Yes. No. Put up here. How would you get moles of O2? Put it down below. So what's going to go up here? So close, so we're really close. No. All on one. No.
How confident are you about that answer?
I'm pretty sure that's right because I know that 1 mole is 6.02 times 10 to the 23rd, so.
Cool.
That's what you're looking up here for. That's what you're looking up there for.
Would we write 2H2O on top, maybe?
No, because that doesn't show the molecular mass.
Yeah.
It's just an equation.
It is like this. No, because there's 2 O's.
So we're in moles now. Now we got 1 O.
No, that's the coefficient. So the coefficient's like
Would it be 16 oxygens or is it just 1 oxygen? It looks like.
So close, so close.
Oh man. I'm stuck. I don't know where to go. Yeah, you're not doing it.
Okay, wait. That would be equal to what? No, because
I'm pretty sure you have to cancel what is it? These first. The H, the hydrogen, and the oxygen first.
that's why you put hydrogen up here, and then you have
And then now you
oxygen over here.
But don't you like to cross off the graph?
What'd you get? Put that answer out. Find that answer.
Wait, what's it?
said it was 16 grams of O2, 32 grams of O2, 1 mole O2, and then you have, this will be 1 mole.
Alright, we got an answer. Close. Okay, let's figure this out. Here's the trophy.
Hey, it's called cheating on that one.
Nah, they cheated. They cheated at something.
Go to instant replay.
Okay, instant replay.
Challenge.
Okay, so let's figure this out. Let's figure this out. So we have 16 grams of O2. Everyone has that on their paper. Everyone has 16 grams of O2. All right. Now, we have, a lot of you are like, well, let's convert to moles, because if we want moles of water, we should probably convert to moles of oxygen, right? And how did you do that? Right? Daniel, how do you convert to moles of oxygen? I know you haven't been here for a week.
I don't remember.
Look at your paper. What did they do? Karen, help them out.
You divide by the molar mass.
Good, molar mass. And Daniel, do you see how the molar mass of oxygen is 32, right?
Yeah.
So we have 32, so grams cancel. So we have a mole of O2. Does everyone agree? We know. 16 over 32, we have half a mole of O2. 16 over 32 is half a mole. Okay? Now, even if you didn't know what to do next, remember how if we use this Pickett-Fitts method, we can be like, okay, well, moles of O2, we want that to cancel, right?
Yes, it goes on the bottom.
So put it on the bottom. And then like, we want moles of water, so put it on the top. Now we just have to figure out, well, how do we relate moles of water to moles of oxygen? And how do we do it? We look at the coefficient. Because the coefficients of a balanced equation, right, shows us the ratios of how much reactants and how much products is going to be produced. So, how many moles of oxygen are how many moles of water are produced per mole of oxygen? It's 2 to 1. So what do we do here? We put a 2 here and a 1 here. Where do I get those numbers from? From the coefficients. So let's figure this out. 16 divided by 32 is a half. Half times 2 is 1/2 times 2 over 1 is 1 mole of water. How many grams is that? 1 mole of water? Oh, yours not how many molecules. We have to look at our molar mass. Right? It'd be 18. Okay. This thing right here, in your notes, this thing right here, I want you to square this in. Square this in. That's what we need to learn today. That is what we call our molar ratio. That is our molar ratio. So what is a molar ratio? All right, now I'll tell you. Write it down. What is our molar ratio? So the molar ratio is the coefficients in a balanced chemical reaction that can be used to determine our relative number of molecules and moles in a compound. And this is the step that we didn't know about until today. So we have to use those coefficients to be able to relate the reactants and the products. So we call it a molar ratio. So the coefficients in a balanced chemical equation can be used to determine the relative number of molecules or moles involved in a chemical reaction. So again, let's just shout out. How many moles